Hello once again. Um, Here I'll be looking at a question that focuses on hyperbola from one of the past papers. So this question will be touching on how to find the equations of asymptote, how to sketch the graph itself, and some other questions such as where our function is positive or negative, where we apply the inequalities uh, in these functions. And it touches on the axis of symmetry as well. So, but before I answer the question or display the question, I would like to start with what are the requirements for sketching a graph. So for us to sketch a graph, we need what we call x-intercepts. We also need y-intercepts. That's one intercept though. And what are these intercepts? These are points in which the graph cuts the x-axis and y-axis. And for every x-intercept, you must let y to be 0. And for y-intercept, you must let x to be equals to 0. So with that being said, another thing that we need to look at is asymptote, lines of asymptote. Where we talk about horizontal asymptote and the vertical asymptote. So we already spoke about this. We said y is equals to q and x plus p is equals to 0, which then gives us x is equals to negative p. So those equations will be useful in terms of drawing the graph and also finding the axis of symmetry. Yes. So let's go straight to the question. So this was adopted from one of the past papers from the DBE website, 2023 May-June paper. Although it is examinable in grade 12, so it's grade 11 work that is examinable in grade 12. All right. Now we are given the function. Let us look at the equation given to us. We are given that f of x is equals to 4 over x minus 1 plus 2. So first, I want us to look at what kind of shape are we going to have. If you look at the numerator, remember we said our a value, if it's greater than 0, then our graph will appear in the first quadrant and third quadrant, like that. So we expect a graph that looks like this. All right. So that's us trying to do 4.2.3 or have an image of what we are going to deal with. All right. So let us look at 4.2.1. 4.2.1 is asking us to write down the equations of the asymptote. You remember that I mentioned that equation of asymptote, it's y is equals to q and x plus p must be equals to 0, and we solve for x. So let me start with vertical asymptote. Vertical asymptote, it is our the x asymptote. So we take the denominator, x minus 1, then we equate it to 0. Therefore, x is equals to 1. That is the first equation. Then, horizontal asymptote, it will be y is equals to the q value, which is, in this case, 2. Note, this is your q, this is your p. You get that? So there, x is equals to 1 and x is equals to what? 2. So these are equations of asymptote. If we were asked to write the equations of asymptote, this is what they are looking for. All right, so 4.2.2, calculate the x-intercept. So we mentioned that for any x-intercept, we must let y, which is the same as your f of x, to be 0. If your f of x is equals to 0, then we have the following: 0 is equals to 4 over x minus 1 plus 2. Once we have that, we can do our maths. Let's take negative 2 that side, 2 that side. Then we have negative 2, that is 4 over x minus 1. If we cross multiply that, we're going to have negative 2 multiplying x minus 1, which is equals to 4. Then we can distribute the 2 into the brackets, or we simply divide both sides by negative 2, whichever works for you, then you go with it. So if I do the distribution, it will be negative 2x plus 2, which is equals to 4. And take the 2 over, that will give us negative 2x is equals to 2. And our x value is therefore negative 1. If we divide both sides by what? By negative 2. So the coordinate there would therefore be negative 1, because we already said our y value is 0. There is our coordinate of the x-intercept. All right, the next question now is asking us to sketch the graph. Note, I mentioned for sketching a graph, you need x-intercept, you need y-intercept, and you also need the asymptotes, horizontal and vertical asymptote. We already answered the question about asymptotes. We answered a question now about the x-intercept of the function f, but we don't have the y-intercept. We can therefore find the y-intercept first, thereafter we can sketch our graph. So let us find that. That is us answering for point 2.3. So for y-intercept, as much they didn't ask us to find it, we need to find it. Let x be equals to 0. So in that case, our x value is 0. So wherever we see x, we replace it by what? By 0. So this is going to be 4 divided by 0 minus 1 plus 2. Then you can use your calculator quickly and you get your answer there. 4 divided by negative 1 is negative 4 plus 2. That will give us negative 2. So the coordinate form of this, because we said x is 0, then y will be negative 2. So we have the x-intercept in which we calculated here, and now we have the y-intercept. So we also have the asymptotes. Let us get on and draw our graph. All we want is just a neat sketch. It doesn't have to be point to point, All right, so let's start with the asymptote. Remember we had x equals to 1, and we had y equals to 2. Let's see if I can use my ruler here so that it it's looking nice now. Let's have it at 0 degrees. C1 so that it aligns with my graph. Okay, this is now not doing what it should be doing. Okay, that's a waste of time now. Okay, sorry about that. I was hoping that it will help me to achieve what I wanted here. Okay. Just do it. Never mind that it's not straight, but you can see that these are my asymptotes. Right. Okay, this is the line. Y is equals to 2, and this is the line x is equals to 1. So let us now plot x-intercept and y-intercept. So let me have my y is equals to -2 here. Y-intercept. X-intercept, you said it's -1 and 0. So therefore it will be here. All right, so with those 2 points, we can get a direction of how our graph would look like. You see that? There, like that. So just bear with me, it might not hit straight to the points, but I'll try to manage it like that. Yep. There. Oh, nice now. You see? I just there's our graph. You can see it's looking nice there. Then you label your points. This is -1 and this is -2. So now remember, hyperbola has 2 parts. So now you can see that our x-intercept and y-intercept are giving us one side of the graph. Because you know the shape, you know how the graph should look like. So you know the other arm should be in the what? In the first quadrant of the asymptotes. So there, look at that. Look how beautiful that is. Yeah. That's our graph then. But if you want to be convinced that it will look like this, you can use a table of values where you substitute values are more than 1. Then you get to see your shape. Also consider decimal values. So this is 2 and this one is 1. I can use a different color. This is 1 and this is 2. Get that? So that is your graph. Remember what they said we must indicate. We must indicate all, label all asymptotes and indicate the intercepts with the x's. So they never specified which intercept, but they said intercept. So that means you must consider all of them. All right. Then that's our graph. The next question is asking us to deal with this. All right, for us to deal with that, we need to also understand our equation. How is this related to that? If you note, the left-hand side is 4 over x minus 1. The left-hand side is 4 x minus 1, but they said is greater than or equals to -2. Okay, you see this looks like that without a 2. But we can take the 2 this side. If we do that, what are we going to have? We're going to have 4 over x minus 1 plus 2, which is therefore greater than 0. You see that? If you look at this now, it looks exactly like our f of x. So this whole expression here, this one, it is our f of x. So this is our f of x. So f of x is now equals to 0. So let's read the question again. Use your graph to determine the values of x for which f of x is greater than or equals to 0. What is the indication of this? I want you to understand that f of x simply means y. F of x simply implies what? Y. So y is greater than or equals to 0. The y values of the graph. These are the y values of f that are more than 0. Where do we find such in our graph? We find it above the x-axis. Above the x-axis, that's where we find y values that are greater than 0. That's the first. And also we are considering this y being equals to 0 too. Y greater than 0, these are values of y above the x-axis. Y is equals to 0, that means we are at or on the x-axis. So therefore, let's go back to our graph that we drew and make analysis of this. There is our graph. They said we must look for where the graph it is above the x-axis. So let's see, look for I think blue would do. Now this is your x-axis, and here that's where y is 0. This is your y-axis, and that's where x is 0. So we can call this line x is equals to 0 and y is equals to 0, just like that. All right, so let us look at where our graph exists above the x-axis. This is our x-axis, this one. So where do we see our graph above? From the far left, can you see that our graph is continuing to go in that direction? So here, our graph, it's above. I hope you can see that it is above. And we also see it here as well. Our graph is still above what? So let us trace the points where this graph is above. So if we look at this asymptote here, okay, let me use a different color, maybe it might help. This asymptote here. So this asymptote here, anything going that direction, our graph is above. You can see that this graph is appearing above. And going in that direction, our graph is above. So if you look through this point at x is equals to -1, going in that direction, our graph appears above the what? Above the x-axis. And this side, just from 1 going to the right, our graph still appears above. So that those are the points that we are looking for. So you can see that the x values are smaller than -1. So that means we are going to say, okay, when x is less than -1, our graph will appear above the x-axis. And again, let us look at something here. From y, the x asymptote, vertical asymptote going to the right, referring to this. Remember here it's 1. As we go to the right of 1, we see that our graph it's above the x-axis. Therefore, we are going to say x is greater than 1. But note, they also mentioned f of x being greater than or equals to 0. So at this point, at -1, the function is equals to 0. Y value at -1 is 0. Remember I said f of x greater than or equals to 0 implies y values of f that are greater than or equals to 0. So they are equal to 0, or the y value is equals to 0 at -1. Therefore, hence I'm including that equals sign there. So this will be your solution for this question. So we come here and say the solution to this will be x, it's less than equals to -1, or x is greater than 1. So that will be your solution. So it's important that you understand your function. Yes. So with that being said, that will be your solution. All right, that answers. Right. So let us look at the last one here. 4.2.5. How can we then answer 4.2.5? It says determine the equation of axis of symmetry of f of x minus 2 that has a negative gradient. You remember I mentioned things such as this negative gradient, but the difference now is that there's something that happened. There is transformation involved. You remember when I mentioned that if I have f of x minus p, what is the indication? Or when I mentioned f of x plus p, if you still remember this. So that's where this comes in now to say, okay, minus 2, which means we are moving to the right, plus 2, we are moving to the left. You know, p always tells a lie. I hope that is clear. So first we need to find the new function. Or we can simply shift every x value by 2 units to the right. So that will be this would be 4, remember? Wherever we see x now, we are going to say x minus 2. Remember, there's also this minus 1 there. So, minus 1. So what we did, we simply replaced x with x minus 2. Plus 2. Then now let's simplify this one. If we simplify this, we are going to have 4 over x minus 3 plus 2. So with that, we can then use negative slope y is equals to negative x plus p plus q. Then remember, we take the denominator as it is. That will be x minus 3. Then we add a 2 there. Then let's multiply out with the negative 1. So that will be negative x plus 3 plus 2. Then this would be negative x plus 5. Then there is your equation. Then this answers the 4.2.5. That is the axis of symmetry with the negative slope. I hope this question answered a number of factors, or addressed a number of factors that maybe you didn't think of, and especially with 4.2.5, because it involves some transformation that I spoke about in lesson 1 of this hyperbola function. So you can refer to it again. You note that it is applicable to this question again. So P always tells a lie. Remember that x minus 2, we are moving to the right by 2 units. X plus 2, we are moving to the left by 2 units. I hope this was as useful video in addressing factors that you had challenges on, especially when it comes to a hyperbola function. I will look for more questions and attend to them, maybe 2 or 3 questions where we address other factors as well. But thank you for watching. I hope you enjoyed the explanations given to this question. Please subscribe and share with others. I thank you.